Check your video out now, man. Like, comment, subscribe.
Now that I have a game plan for controlling these monster injectors, and we can now source our outputs coming from the Motec and using an injector driver box to control these bad boys. Now that I have a game plan set up for controlling these big boy injectors, and I definitely didn't want to get rid of those bad boys because these injectors, they fit into the grand scheme of being able to flow enough fuel to support a broad range of horsepower. And I mean big boy horsepower. Basically, just to give an example, these injectors can support anywhere from 1600 to 1800, pretty much 1850 wheel horsepower alone, with 85% duty cycle and a static field pressure of 45 psi. Our baseline static field pressure is going to be 50, but just even at 43 psi field pressure, these boys can support some big boy field. That's not even including running the additional 6 direct injectors that'll be on the system. So basically, the system has enough potential, and the weakest links will be our fuel pumps. Whether we upgrade to bigger electronic fuel pumps or a mechanical fuel pump, the injectors are pretty much there to supply that fuel. So that's basically what I wanted to do. The next game plan is to continue to calibrate the rest of these sensors. I only have a few more that I need to do, and I will mock up pretty much a plate to support the Motec unit as well as the Field Tech. I'll mount these side by side up under the windage tray right where the original ECU was located, and we can just put these together on some type of, it could be an aluminum support pan itself that'll keep both mounted side by side. I'll have the input wires flowing into this, and this pretty much shooting the output wires going over to the 6 port fuel injectors. So that's basically the game plan for that. And we can keep it moving. Now that we've done that, that's our strategy. We can get back on the bench and continue configuring this low pressure fuel sensor. So back at this, let's get a pointer or a pencil so I can explain a little bit more. Basically, now that we have assigned an input to this fuel pressure sensor resource, this opened up a whole broad range of other parameters that was sitting in the background waiting to be utilized, but all we need to do was assign an input. Oh man, I'm tired. I've been up all night. That means it's time to wrap it up. That's what that means. So we'll get ready just to do a few more things and then call this a wrap. Now that we had that assigned, there's still a few more things I would like to do. I'm losing my voice because I've been talking so much, and that's why I gave up the job as a trainer in my field of operation. So now that we have that, is a few things I would like to change, even this right here. So our units of measure, I want to change this from kPa to PSI. That's one of the things I want to do, as well as get rid of this and change this to a 2-point table. So let's go through and set this up for PSI. So to change the display units, let's see if I can do this and hold the phone. We'll hit Control N. And let's go to our drop down from kPa, kilopascal, to PSI. And you do not want to use PSI absolute, because then you'll be starting off with a baseline pressure of 14.7 PSI. And we don't want that. We want to read actual gauge pressure. So that way, if I had selected, for example, absolute PSI absolute, like I said, I'm getting tired from even hearing myself talk. If I had selected that, it will start my system off with a baseline field pressure of listing 14.7 PSI, even though there will be 0 PSI coming from my field pump, and we don't want to do that. So we want to just start off basically PSI and select OK. Then we can go over here to this table and set up our voltage calibrations. We would hit A for that. And let's set up our scales for our sensor itself. Our sensor at 0.05 volts. That is 0 PSI. And let's go to the next one at 4.5 volts and select enter. There we go. Now you see our new plot right here. 4.5 PSI would equate to 145 PSI with 10 bar, and this is 0. So we are pretty much scale for that. We will hit OK, and now we have our 2-point axis table, and that pretty much gets us somewhat set up a little bit. We'll go ahead and start continuing setting the high and low settings for the sensor for any type of fail points. And for example, field pressure sensor diagnostic low, and for our diagnostic high, that's a little bit higher than we want, 4.9. I'll probably take that a little bit. I'll say probably somewhere around 4.6. 4.7, and for the low, I probably will set the low a little bit different. But either way, let me just call that a wrap for the night. I'm tired, I'm losing my voice, I'm getting sleepy, and it's time to take a break. So that's it, folks. We'll continue with this another day. And back before I shut my computer off, let's make sure I enter the proper number in here before I hit save, so I don't waste my time and energy for nothing. So here, I would want to set this for 145 PSI. 45, enter. There we go. That looks a lot better. I was about to close the lid of my laptop, and when I saw my scale reading minus, I'm like, that does not look good at all. That looks a lot better. 0.5 volts, 0 volts, 0.5 volts, 0 PSI, 4.5 volts, 145 PSI. There we go. That scale looks a lot better. All right, Control S, and that will finally be it. Control S, save it. There we go. All right, we'll pick back up. I'll double check myself later tonight or tomorrow and continue with the flow. But it's not good to work or play with numbers and figures while you're sleepy or tired or exhausted. I did write the information down so I can try to keep track of it, but either way, I would have still came back and checked, or my field pressure would have been reading jacked up, and I would have had no choice but to come back and look at my settings. But basically, that is it. We do have a baseline, and we're getting this bad boy right here set up to read some field pressure. Finally, that's it.